Welcome everyone to our plane measuration series, the SSC aspect of it. Today we are dealing with perimeter area of a sector. First, let us take perimeter of a sector. We have a given diagram for any cycle with center O and radius R from which a sector AOB is formed. The perimeter of the sector is the sum of the two radar and the length of the arc AB. Since perimeter is the distance around a given shape, thus we can say perimeter of a sector is equals to 2R plus L of arc, that is length of an arc, where L of arc is equals to theta over 360 times 2 pi r. Next, let's take some examples. 2007/35 NECO. The angle of a sector of a cycle of radius 5.5 cm is 60 degrees. What is the perimeter of the sector? Take pi equals to 22 over 7. The options are given. Solution. Perimeter of a sector is equals to 2r plus length of arc. Substituting for the given value, that will be equal to 2 times 5.5 plus 60 over 360 times 2 times 22 over 7 times 5.5. And the result is 11 cm plus 5.76 cm. That's equals to 16.76 cm. Another example, 2015-14. A sector of a cycle with radius 6 cm subtend an angle of 60 degrees at the center. Calculate its perimeter in terms of pi. The options are given. Solution. Perimeter of a sector is equals to 2r plus length of arc. Substituting for the given value, that will give us 2 times 6 plus 60 over 360 times 2 times pi times 6. And the result is 12 plus 2 pi. Factoring out 2, we have 2 into bracket open 6 plus pi bracket close cm. Another example, 205/42 odd. OX and OY are radii of a cycle center O. If OS is 4 cm and angle SOY is 60 degrees, calculate correct to the nearest whole number the perimeter of the sector XOY of the cycle. Take pi equals to 22 over 7. The options are given. Solution. From the given information, we can sketch the diagram as shown on the screen. Next, our perimeter of a sector is equals to 2r plus length of an arc. Substituting for the given values, that will be 2 times 4 plus 60 over 360 times 2 times 22 over 7 times 4. And the result is 8 plus 4.19. That will give us 12.19 cm, which is approximately equals to 12 cm to the nearest whole number. Another example, 2012/17. A sector of a cycle which subtend 172 degrees and the center of the cycle has a perimeter of 600 cm. Find correct to the nearest cm the radius of the cycle. Solution. Perimeter of a sector is equals to 2r plus length of arc. Substituting for the given value, that will be 600 equals to 2r plus 172 over 360 times 2 times 22 over 7 times r. Note we are looking for r. The result is 600 equals to 2r plus 7568r divided by 2520. Applying LCM principle to the right hand side, that will give us 600 will be equals to 5040r plus 7568r divided by 2520. Simplifying, we have 600 equals to 12608r divided by 2520. Cross multiply to clear fraction. The result will be 1512000 will be equals to 12608r. And to get r, divide both sides by the coefficient of r as shown below. Thus r will be equals to 119.92 cm, which is approximately equals to 120 cm to the nearest centimeter. Next, we take area of a sector. The area of a sector AOB of a cycle of radius r of center O is given as area of sector equals to theta over 360 times area of cycle, which is the same as theta over 360 times pi r squared. Let's take some examples. 2065A napted. Calculate the area of the major sector of a cycle which subtends an angle of 130 degrees at the center and having a radius of 14 cm. Take pi equals to 3.14. Solution. Area of sector is equals to theta over 360 times pi r squared. Here we are dealing with major sector. Thus, the area of a major sector will be equals to 360 minus 130 divided by 360 times 3.14 times 14 squared. And the result is 230 over 360 times 3.14 times 14 squared. And that will give us 393.20 cm squared. Another example. A sector of angle 120 degree is cut out from cycle of radius 13.5 cm. What area of the cycle is remaining? Take pi equals to 22 over 7. The options are given. Solution. Area of a sector is equals to theta over 360 times pi r squared. Here, theta is equals to 360 minus 120, which is 240 degrees. Thus, substituting, we have 240 over 360 times 22 over 7 times 13.5 squared. And the result is 381.857 cm squared, which is approximately 381.9 cm squared. Another example. XOY is a sector of a cycle center O of radius 3.5 cm, which subtends an angle of 144 degrees at the center. Calculate in terms of pi the area of the sector. The options are given. Solution. Area of sector is equal to theta over 360 times pi r squared. Substituting for the given value, that will give us 144 divided by 360 times pi times 3.5 squared. The result is 4.9 pi cm squared. Another example. In the diagram below, O is the center of the concentric cycle of radii 30 cm and 10 cm respectively. Find the area of the shaded portion in the sector with an angle of 120 degrees at the center. Solution. Area of shaded portion is equals to area of big cycle sector minus area of small cycle sector, since we are dealing with concentric cycle here. And the result is 120 divided by 360 times pi times 13 square minus 120 divided by 360 times pi times 10 square. Simplifying, we factor out 120 divided by 360 and pi out. That will give us the result below. Since we have a difference of 2 square in 13 square minus 10 square there, we simplify as given next, which will be equals to 1 over 3 pi into 3 times 23. And that will give us 23 pi cm square. We've come to the end of the examples under this subheading. Next, we have some exercises on page 251 and 252 of the hidden fact in new SSC mathematics. Please try your hands on the exercises. The answers are given at the answer section of the book. The hard copies are available in bookshop. If you're interested in the soft copy, visit our website, whose address is shown at the bottom of the screen. Thank you.